Dear students, today we will be discussing some problems related to surface, line and volume integrals. You can see a MCQ. In this question, we have to find a surface integral of a given vector field A over a surface S. Now, four options are given there. You can see um, in surface integrals, we have two methods. Either we can proceed directly or we can solve them using Gauss Divergence theorem and Stoke's theorem. In this particular problem, the nature of the problem is such that we have to find the surface integral A dot n ds. It means that either we'll be using direct method or we will be following Gauss Divergence theorem. Now, what does the Gauss Divergence theorem state? According to the Gauss Divergence theorem, if we have a closed surface S, means that the surface should be a closed one enclosing a certain volume V, and there is a vector field A which is differentiable along this surface and has continuous partial derivatives. Then the surface integral A dot n ds over this closed surface is same as the volume integral of divergence A. So this is the Gauss divergence theorem. But for Gauss divergence theorem to be applicable, the surface should be a closed surface. And one more thing, the n cap is the unit normal vector coming out of the surface of the closed surface S. Means in this particular diagram, n cap will be as shown in the figure. Now, in the given question, the first problem is that S is not a closed surface. S is the surface of cylinder x square plus y square is equal to 16 included in the first octant between z is equal to 0 and z is equal to 5. What type of surface is this? This is an open surface. If we trace this, we will get something like this. Suppose this is z-axis and this is x-axis and this is y-axis. Then first we will trace a circle x square plus y square is equal to 16 in the xy plane. This is 3D, so the circle may not look like a circle, but it is actually a circle of radius 4 and center origin. And then the cylinder will be n cap being away from the coordinate planes, and S is the surface of the cylinder only. It means that here n cap is coming out, or we can say being away from coordinate planes, like this. So the first problem is that the surface is only this part of the cylinder which I am shading, and this is not a closed one, not a closed surface. So if we want to apply Gauss Divergence theorem, we will have to form a closed surface of which it is a part. So this will be a rather difficult job to be done, to make it first a closed surface by adding a few more surfaces and then applying the Gauss Divergence theorem, and then to find the surface integral over S only, we will have to subtract the surface integrals along the new surfaces added. Like if we want to make it a closed surface, we will have to add some more surfaces into it. Suppose this surface is S, and suppose this surface is S1 at the top, it is S1 at the back side. Suppose this is S2 at the bottom. Suppose this is S3, and at the back side, this one lying in the ZY plane at the back side, suppose it is S4. So S4 at the back side. So total S union S1 union S2 union S3 union S4 means combination of these 5 surfaces will make it a closed surface. Alone S is not a closed surface. S is the surface of the cylinder. Cylinder means not S2, not S4, not S3, not S1. Cylinder is the part of cylinder is only S here. S4, S2, S1, S3 and S5 are the bounding surfaces which are helping us to have a closed surface. So now this is a closed surface, and we have to find the surface integral along S only, not along this S1, S2, S3, S4 and S all. So applying Gauss Divergence theorem is a difficult job, and it will be a more time taking job to be done here. So I think that the direct approach will be a better approach to solve this problem. So we will determine this surface integral by direct method and not using the Gauss Divergence theorem. First, we have to find n cap, and we know that n cap is gradient phi upon mod gradient phi. So here, what is phi? Phi is actually x square plus y square minus 16 here. So what will be gradient phi? Gradient phi will be 2 times xi cap plus yj cap, and what is mod of gradient phi? Mod of gradient phi will be 2 times square root of x square plus y square. So 2 gets cancelled, and we get xi cap plus yj cap divided by, what is x square plus y square? Actually on this along this surface, x square plus y square is 16. So square root of x square plus y square will be square root of 16, that is will be 4. So here n cap is xi plus yj upon 4. Now to determine this surface integral, we have to find projection of S on one of the coordinate planes. Obviously this surface is perpendicular to xy plane, so we cannot take projection on the xy plane. Rather, we will have to take projection on either xz plane or yz plane. So here we take projection of the given surface of the cylinder, part of the cylinder, on the xz plane, and the projection is, I'm shading the projection with green color. You can see, suppose this projection is R, then I have already told you a formula to find ds, and ds will be equal to square root of 1 plus, since we are taking projection on the xz plane, so it will be debur y upon debur x square plus debur y upon debur z square into dx into dz. So it will be, if we determine debur y by debur z, so the equation of the surface is x square plus y square is equal to 16. It means that from this equation of the surface, debur y by debur z is 0, and debur y by debur x, yes, we can find debur y by debur x from here, and debur y by debur x from here, it will be 2x plus 2y debur y by debur x is equal to 0. So the value of debur y by debur x is uh, minus x upon y, and the value of debur y by debur z is actually 0 here. So if we substitute the value of debur y by debur x and debur y by debur z in this expression for ds, we get ultimately 1 plus x square upon y square into dx dz. Now this is square root of x square plus y square upon y square, and again along this surface S, x square plus y square is equal to 16, so we can substitute here. So it will become x square plus y square, square root means square root of 16, that is 4 upon y, actually it should be mod y, because square root of y square is not y, square root of y square is mod y, so I am writing mod y here, multiplied by dx dz. uh, Mod y gives us the positive value of y, and if we solve x square plus y square is equal to 16 for y, we will get y is equal to plus minus square root of 16 minus x square. So we take the positive square root, and we get the value of y as square root of 16 minus x square. So we can write here uh, 4 upon square root of 16 minus x square into dx into dz. So in this way we have obtained the value of ds. This is 4 upon the square root of 16 minus x square into dx dz, and we have also obtained the value of n cap. Now we will substitute the values of n cap and ds in the given surface integral, and yes, when we are using this value of ds in terms of dx and dz, then the resulting surface integral will not be determined over S. Now since we have taken projection over R, so the resulting surface integral will be determined over R. If we look at this projection R of the curved surface of the cylinder S on the xz plane, we can easily see that R is actually a rectangle. Since the height of the cylinder was from z is equal to 0 to z is equal to 5, it means that this height is 5 and this base is 4. Since the radius of the cylinder is 4, it means that from this point to this point, this length is 4. It means that corresponding to this projection shown in the xz plane, this side will be 4 and this side will be 5, and R is a rectangle. Now, if we substitute the values, different values of a, n, ds, and now the resulting surface integral is over R, we can rewrite the given surface integral as now an integral over R with a. A was z into I cap plus x into j cap minus 3y square z k cap, taken dot product with n cap, and n cap was xi plus yj divided by 4, and ds, yes, uh, ds was 4 upon square root 16 minus x square dx into dz. So we use this value here, 4 upon square root 16 minus x square dx dz. So since R is rectangle, so it is very easy to see that the limits of R are from the limit of z will be from z will be from 0 to 5, and the limit of x will be from 0 to 4. And now taking dot product, we get zx plus xy, 4 gets cancelled, there is no k cap here, so only zx plus xy upon divided by 16 minus x square dx dz. So it becomes 0 to 4, 0 to 5, zx upon square root 16 minus x square dx dz plus 0 to 4, 0 to 5, x upon square root 16 minus x square into y. Now the most important thing is that we are integrating over s, and the equation of s is given as x square plus y square is equal to 16, and in the positive octant x, y, z all are positive, and so the value of y we will substitute y is equal to 16 minus x square. So we will substitute this positive root here, and if we put y equals square root 16 minus x square, gets cancelled, and dx dz only. So we can very simply very easily solve this this double integral here. If we integrate with respect to z first, we get z square by 2, and the limits of z are from 0 to 5, so simply we get 25 upon 2 uh, x upon 16 minus x square dx. Sorry, this will not be a double integral now. should erase it. Yes. So this will be a single integral, and the limit of x will be 0 to 4 in this part, and the remaining part is if we integrate with respect to z first, we get 5. We can take it out of the integral, and remaining part is x. We will get x square by 2. The limit of x is from 0 to 4, so we get 16 by 2. It means 8. And for this part, if we substitute 16 minus x square is equal to t square, we will get x dx is equal to minus t dt, and we will get minus t dt, and t here also t will get cancelled, so we will get minus dt only, and the limit of t will be from minus dt only, and the limit of t will be from 4 to 0. So simply we can write it will be 4. It means that 25, we get 25.2 into 4 plus 8 into 5 is 40, and we get ultimately to 50 plus 40 is 90. So the option A was correct, it was 90. So what we learned from this particular question is that we should not be hurried to use Gauss Divergence theorem. Sometimes if we apply Gauss Divergence theorem in a hurry, we can get to a wrong answer, because actually this surface is not a closed one, and for converting it to a closed surface we will have to add many other surfaces, like I told you earlier, S1, S2, S3 and S4. So that approach may be a bit lengthy than this approach, the direct method. Now we come to another problem asked by Tushar. In this particular question, we have to find the surface integral of curl f. Look at this carefully. This is not f. This is curl f. We have to find the surface integral of curl f over a given surface S. And more important thing is that S is the surface of sphere x square plus y square plus z square is equal to a square above the xy plane. So first thing that I would like to tell you, Tushar, is that uh, this is still not a closed surface. Actually, this surface is the part of a sphere above the xy plane. So you can, if you trace it, something like this, you will get. This is just the part of sphere above the xy plane and not below the xy plane. So this is hemisphere. This is not the complete sphere, and it is open. It is open from this side. This is not a closed surface. Okay, so it means that uh, you cannot apply the Gauss Divergence theorem straightforward. And I think I have told in the class, already told in the class, that in case you have to find you want to find the surface integral of curl f, then you should be using Stoke's theorem, and Stoke's theorem is a better choice. Stoke's theorem is a better choice to be followed here. And I actually, you asked this problem to solve using Gauss Divergence theorem. I will solve this problem with the help of Gauss Divergence theorem also. But first, let me tell you what is the appropriate approach to solve this problem. Okay, so I will be solving this problem using Stokes theorem. What does the Stokes theorem state? According to the Stokes theorem, uh, curl surface integral of curl f dot nds, where S is not a closed surface, it is an open surface, is actually f dot dr over c. What is c here? So c is actually the boundary, the bounding curve of the open surface. Here you can see that if you take a inverted ball, so you will get a bounding curve of this hemisphere, inverted hemisphere. This is c here. So first you should write the equation of c. And what will be the equation of c here? It is actually, this circle lies in the xy plane. This circle lies in the xy plane. So if I trace this circle, I will get something like x, y, something like this, and the radius of the circle is a. So x will be a cos theta, y will be a sine theta, and this lies in the xy plane, so z will be 0, and this complete circle, so theta will vary from 0 to 2 pi. Now if we find f dot dr will be x square plus y minus 4 multiplied by dx plus 3xy into dy, and dz will be 0. Since z is constant, z is 0, it means that dz will also be 0. So we get only this. Theta is from 0 to 2 pi. Now if we substitute the values of x, y here, this, I think, let me see the question again. It is not a square, actually a is given, it is actually 16. So we can write a as, we can take the value of a as 4. So what we get from this, x square will be uh, 4 square cos square theta, 4 square cos square theta, plus y will be uh, 4 sine theta minus 4 to dx will be minus 4 sine theta d theta plus 3xy. So it will be 3 into 4 square means 16 into cos theta sine theta, and dy will be 4 cos theta d theta. And now we have to integrate from 0 to 2 pi with respect to theta. So now we get here we get uh, this is 16 into 4 minus 64 cos square theta sine theta, cos square theta sine theta d theta, uh, minus 16 sine square theta, and then plus 16 sine theta, and then it is 64 multiplied by 3, it is 192 plus 192 cos square theta sine theta d theta, and the limit of theta is from 0 to 2 pi. We can simplify it further. It is Now it is 192 minus 64 makes it 128. So it is 128 0 to 2 pi cos square theta sin theta d theta minus 16 times 0 to 2 pi sin square theta d theta. And yes, if we use some simple properties of definite integral, we can say that this integral will be 0. Also this integral will be 0 because sine 2 pi minus theta is minus sine theta, so this integral will be 0. And the third integral, if I write it 16 times sine theta d theta, this third integral will also be 0. So we will only remain with only this term minus 16 times 0 to 2 pi sine square theta d theta. So if we solve it further, sine square theta, we can write sine square theta as it is minus 16, and sine square theta we can write it 2 sine square theta by 2, so it will be 1 minus cos 2 theta by 2 and d theta from limit 0 to 2 pi. If we integrate it, the integration of cos 2 theta will be 0, and we will get only 1 by 2 into 2 pi, so we will get only pi. So the answer is minus 16 pi. So the right answer is minus 16 pi. Now as asked, I will solve this problem with the help of Gauss Divergence theorem also. Now, if we want to solve the given problem with the help of Gauss Divergence theorem, then we first have to make sure that we have a closed surface in hand. The given surface S was not a closed surface, it was just a hemisphere. Actually, it was part of the sphere x square plus y square plus z square is equal to 16, lying above the xy plane. So first, we have to convert the given surface, or we have to extend the given surface to make a closed surface. In order to do this, what I am going to do is, now I will add another surface, say S1 or S dash. So now I will be adding another surface S dash to the given surface S, so that S union S dash becomes a closed surface. You can see that actually S dash is a plane surface. Actually it is the part of the circle. The circle is x square plus y square is equal to 16, lying in the xy plane, and S union S dash is a closed surface. And we have to find curl f dot n ds over S. But with the help of Gauss Divergence theorem, we will be able to find the surface integral of curl f dot n ds over S union S dash with Gauss Divergence theorem. Because S is not a closed surface, S union S dash is a closed surface. Now if we break this surface integral to two parts, one with respect to S, curl f dot nds, and the other one curl f dot nds again over S dash, it will be equal to, using Gauss Divergence theorem, it will be equal to divergence of V. Actually, this V is here curl F. So divergence of curl F dV, and we know that there is a vector identity that that which says divergence of curl F is always 0. So whenever you try to find you try to apply the Gauss divergence theorem in this type of problems, you will be obviously taking divergence of curl F, and divergence of curl F is always going to be 0. You will always be getting 0, which is a wrong answer. It is a wrong answer because actually you have to find the surface integral over S, which is not the closed surface. And every time you want to use Gauss Divergence theorem, you have to convert, or you have to extend the given open surface into a closed surface. Now what we can do further, if we want to find the surface integral along S, we can using Gauss Divergence theorem, what we can do here is we will write curl F dot NDS is equal to this is 0 0 minus S dash curl F dot NDS. This goes to the other side, becomes negative, and curl F is already obtained, I think. Yes, curl F is 0I minus 2Z into J plus 3Y minus 1 into K. This is curl F dot n cap. What will be n cap? Now, since we are integrating over the surface S dash, n cap will be in this direction, n cap, and this is opposite to the z axis. So n cap, we can take n cap as minus k cap. So here we will take n cap as minus k cap. And one more thing, since the surface S dash is in the xy plane, it means that we can write ds is equal to dx into dy, because the surface S dash lies in the xy plane. So here we can write dx into dy, and the limits of, we have to put the limits only now. The value of z is 0 in S dash, so in place of z we can write 0. So we get only minus, and this minus and this minus makes it plus. K dot k will be 1, so we get 3y minus 1 dx dy over S dash. Now what is S dash? S dash is x square S dash. If we form S dash is nothing but the interior of the circle, x square plus y square is equal to 16. So the limit of y will be under root 16 minus x square, and the limit of x will be from minus 4 to plus 4. So we can write it as the limit of y will be minus 16 minus x square to 16 plus x square, and limit of x will be from minus 4 to plus 4, and you will get 3y minus 1 dx dy. Now if we integrate with respect to y first, we get 3 times y square by 2, 3 times y square by 2, and y square by 2, the upper limit is 16 plus x square and the lower limit is minus 16 minus x square. If we put the upper limit, we get 16 plus x square here, minus again 16. uh, it should not be plus x square, it is 16 minus x square here, and here also it is 16 minus x square. So again 16 minus x square, it will be cancelled. The other part, since it is odd function, so whenever we integrate it from minus a to plus a, it is always going to be 0. The other part is minus 1, and we will get, simply we will get minus y, so we will be getting, in the other part we will be getting minus uh, 2 times root 16 minus x square dx, and limit from minus 4 to plus 4. This becomes, uh, since this is even function, this becomes minus 4 times 2 times means, so 2 into 2 is 4, minus 4 times 0 to 4 square root of 16 minus x square dx. If we integrate it, we can get, we will get x into 16 root 16 minus x square. The upper and lower both limits will be 0, and then we will be getting something like minus 4 times 16 upon 2 into sine inverse x upon 4. And if we substitute the lower and upper limit, they're like 0 and 4. If we put the upper limit, we will get minus 32, and sine inverse 1 is pi by 2, so we are going to get minus 16 pi. So the same answer we are getting again as we obtained with the help of Stoke's theorem. So we can use the Gauss Divergence theorem. Now you all are smart enough and you can decide which theorem you should be using. Obviously, the better choice for such types of questions is not the Gauss Divergence theorem. We should try to solve these problems with the help of Stoke's theorem. And the answer, we are getting the same answer. So this gives another verification of the equivalence of the Gauss Divergence theorem and the Stoke's theorem. So thank you for asking these questions.